Alright guys, this video is going to go over the notes for 7.1, going over ratios and proportions. So to start off, we want to go ahead and talk about what exactly is a ratio. A ratio by definition is a comparison of two or more quantities. And we have a couple of different ways that we can represent a ratio. So if you look here that we're highlighting in yellow, we can write a ratio the following way. We can write it as A to B, or we can write it this second way. This is the two dots right there, that's a colon. That's A colon B, but this is still also read as A to B. And then the third way that we can write a ratio is as a fraction, as A over B, right? So either one of these three ways is an acceptable way to write a ratio. One thing you do want to make note of here, though, that is really important is that ratios can be simplified. Right? And the expectation here is that anytime you're writing a ratio, make sure that you simplify whenever possible. So this will start to make more sense as we look at some examples. So let's go ahead and dive into example one. It says a grocery store has 40 apples, 39 pears, 24 bananas, 51 oranges, and 16 apricots in stock. Right? Each has a simplified ratio. So looking at the first part here, Part A, apples to bananas, well, they want us to write this as a ratio. How can I write the ratio of apples to bananas? Well, let's take a look. How many apples do I have? I see here that we have 40 apples, and the number of bananas here that we have is 24. So if I want to write this as a ratio, we can simply just write this as 40, that's the number of apples we have, to the number of bananas, which is 24. Right, and so we'll typically either write our ratios in this way, or most of the time you'll see that we'll write it as a fraction. So this ratio of 40 to 24 can also be written as 40 over 24. And so, like we mentioned earlier, ratios can be simplified. So our job right now is to simplify this ratio. So whenever you're looking at this fraction or ratio of 40 over 24, we want to simplify it. When you're simplifying a fraction, the way you do this is you're looking for, what numbers can I divide the top and bottom by so that I can reduce this fraction into simplest form, right? And so one strategy that I always suggest is if you're not sure what to divide the top and bottom by, if they're both even numbers, you can always start off by dividing by 2, right? So I can for sure divide the top and bottom both by 2. So on the top, 40 divided by 2 gives me 20. On the bottom, 24 divided by 2 gives me 12, right? But you're going to see here that this still isn't in simplest form, right? So you can keep repeating this process until you get numbers that you're comfortable with. For example here, now I can start to understand that, 20 and 12, I know that both of those can be divided by 4. So if I divide the top and bottom both by 4, we'll see that, what we get here is 20 divided by 4 on the top is 5. On the bottom, 12 divided by 4 is 3. So my ratio in simplest form from apples to banana is 5 over 3, right? So this is just kind of a really quick review on how it is that you can simplify fractions, right? Alternatively, if you are struggling with simplifying fractions, you can take this part right here, 40 over 24, and you can plug that into the calculator, type that fraction in, and you hit enter, and it'll simplify the fraction for you. So with that being said, let's go ahead and go through part B next. So part B, now we're looking at, let's erase this, we're looking at oranges to pears, right? So if I'm looking at oranges to pears, then I'm looking at what is the number of oranges I have? Well, if I read the question, I got 51 oranges. What is the number of pears I have? Well, got 39 pears, right? So oranges is first, so I got 51 oranges to 39 pears. Now, if I want to write this as a fraction, 51 over 39. And so what we would check for here now is we would check, does this simplify, right? And this one isn't super obvious, but I know that I can divide the top and bottom by 3. And if we divide the top by 3, we get 51 divided by 3 gives us 17. On the bottom, 39 divided by 3 gives me 13. So this ratio in simplest form, the ratio of oranges to pears, is 17 to 13, or 17 over 13, right? And again, if you find yourself struggling with simplifying these ratios, you can always type in the fraction into the calculator and it'll simplify it for you. So let's go ahead and move on to part C. Let's erase this. Part C, now we're looking at what is the ratio of apricots to apples? Well, if we look here, how many apricots do we have? Well, we got 16 apricots, so 16 apricots to the number of apples that we have, which is 40. So I got 16 to 40. And so we can write this as a fraction as 16 over 40. And what we're checking for now is, can this fraction be simplified? And it most certainly can. The largest number that you can divide the top and bottom by when simplifying this fraction is you can divide the top and bottom both by 8. Doing so would give us, on the top, we have 16 divided by 8 is 2. On the bottom, 40 divided by 8 is 5. So our ratio from apricots to apples in simplest form is 2 to 5, or 2 over 5. And then lastly, we can finish up with this last example here. Let's use a different color here. Part D says bananas to total fruit. So if we look here, okay, let's use yellow for bananas. And I'm just doing this to make it extremely obvious. I know that you guys are more than capable of just reading the question. Don't feel the need to use highlighters if you don't want to. But we have 24 bananas. So I have 24 bananas to, well, let's see, what's my total fruit? If you read the question, you'll notice that they don't give you the total number of fruit. So if I want to find the total number of fruit, well, we're going to have to do that on our own. If I want to find the total number of fruit, I'm going to have to add up all those values. So 40 plus 39 plus 24 plus 51 plus 16 gives us a total of 170 fruit. So my ratio here would be 24 to 170, right? And if we write this as a fraction, this ratio would be 24 over 170. And so if we want to simplify this fraction to see if it simplifies, I'll be honest with you, I don't know off the top of my head what the biggest number I can divide the top and bottom by is. So like we suggested earlier, you can always start with, if they're both even numbers, which 24 is even, 170 is even, then I can always start by dividing by 2. Make the numbers look a little bit friendlier. So if I divide by 2 here, on the top, 24 divided by 2 is 12. On the bottom, 170 divided by 2 is 85. And then from here, you can go ahead and begin to check too, can I divide this any further? At this point, I'm not entirely sure that we can, so if you're checking with the calculator here, you can type in that ratio, either the 24 over 170 to see if that simplifies, or you can type in the 12 over 85. I'm fairly certain that this does not simplify any further, so our ratio would just stay as 12 over 85. Okay? And so, again, just to kind of briefly recap, when you're writing ratios, just make sure that you're following the order in which it's written, right? So notice that here I put bananas to total fruit. I put the 24 on top and the 170 on the bottom. So you go in the order that it is read, or whenever you read it. So we'll go ahead and jumping ahead to the next section, we're going to start looking at equivalent ratios. So equivalent ratios, by definition, this is going to be two ratios that have the same simplified form. And so what you'll start to notice when you're looking at equivalent ratios is that some of these ratios are going to have units that are different, so unlike units. For us to be able to simplify this, you have to multiply by some kind of conversion factor. And this part right here is going to be extremely important. So a ratio must have a numerator and a denominator. Okay, so whenever you're simplifying a ratio, please make sure that you have it listed as a fraction at the very end. Okay. And so if we look at example 2, it says simplify the ratios. Looking at part A, we have 76 centimeters to 8 centimeters. And so remember that we can write this as a fraction by just writing it as 76 over 8. And so if we wanted to simplify this, I know that 76 can be divided by 4 and 8 can be divided by 4. So when you're simplifying fractions, you're looking for what is the largest number that you can divide the top and bottom both by. If I divide the top by 4, 76 divided by 4 gives me 19. 8 divided by 4 on the bottom gives me 2. So this in simplified form would be 19 over 2. Or if you wanted to write it in the same format, you could say 19 centimeters to 2 centimeters. Either one of these answers are acceptable. And then we run into a problem like part B. You'll notice that our ratio here is 4 feet over 24 inches. And what we're seeing here is that these are different units, right? And so because these are different units, I can't directly simplify. What we have to make sure is we need to make sure that we're working with the same units before we start simplifying our fraction. So let's kind of talk about the feet and the inches. One thing that should be noted here is we need to understand that 1 foot is equal to 12 inches. So using that information, if I know 1 foot is 12 inches, then 4 feet, okay, 4 feet would just be in inches, would be us doing 4 times 12. Those 12 inches in 1 foot would tell us that there's 48 inches in 4 feet. So we can now rewrite this so that we're dealing with the same units. So 4 feet, we just said on the top, that's the same as 48 inches. So I can write this as 48. And then on the bottom, we have 24. And so what you'll notice here is that if I wanted to simplify this, okay, we can understand that this fraction is 48 over 24, or 48 divided by 24. We understand that that is going to give us 2. But whenever you're writing a ratio, you need to make sure that it is a fraction. So this would be 2 over 1. If we were simplifying it the same way we were doing so before, essentially what we did here was we just divided by 24. Divided by 24 on the top and bottom. So our simplified ratio here would be 2 over 1, or 2 inches to 1 inches. Okay. And so now we'll move on to the next part of the notes where we start to talk about extended ratios. So an extended ratio is going to be a ratio of more than 2 quantities. So you have an example right here of kind of what an extended ratio is. An example listed would be A to B to C to D, right? So we can have, a comparison between 3 quantities, 4 quantities, 5 quantities. We can go up to as many quantities as we want, but we understand that it's an extended ratio whenever it's at least 3 or more, so more than 2. So let's look at an example that involves the use of an extended ratio. So example 3 says, the measure of the angles in triangle ABC are in the extended ratio 2 to 3 to 4. Find the measure of the angles. And so there's some steps 1, 2, 3, and 4 listed below to help walk us through this process. So right here, we're going to notice that we're talking about a triangle, right? So the measures of the angles in triangle ABC. So the first thing would be a good idea to start with here is, well, why don't we start with labeling our triangle? Okay, so draw a triangle, which one is already drawn out for us. Let's call this triangle ABC because that's what we're working with. Now it says that the measures of the angles are in the extended ratio 2 to 3 to 4. For these types of problems, we understand that our ratio between all 3 angles in the triangle is 2 to 3 to 4. So what we can do is we can understand that this ratio could be represented as 2x to 3x to 4x. So for these types of extended ratio problems, you're really just tagging on an x at the very end of your numbers in that extended ratio. So what we're going to do now is we're going to label our angles in terms of x, right? Which what we have listed here. So let's say that angle A is the 2x, angle B is the 3x, and angle C is the 4x. And so now we can use what we learned last semester where we looked at what do the angles inside of a triangle add up to? Well, if I'm looking at step 3 here, the triangle angle sum theorem says that the 3 angles in a triangle, right? In this case, we're looking at let me scroll back down here. 3 angles that I have here is 2x plus 3x plus 4x. Those 3 angles in the triangle add up to 180 degrees. And so that gives us an equation that allows us now to solve for x. And then we can start to find the measures of those missing angles. So if I want to start solving for x here, when the x's are on the same side of the equation, you can combine these like terms. So I got 2x plus 3x plus 4x. That gives us 2 plus 3 is 5, plus 4 is 9x. So I got 9x is equal to 180. Now if I want to solve for x, all that's left for us to do is to divide by 9. We get that x is equal to 20. And so one thing we want to just make sure of is after you find the value of x whenever you're solving, go ahead and reread the question. Make sure that you've answered what they're looking for. So what we're looking for here is, it said find the measure of the angles, right? So if I want to find the measure of the angles, then let's go ahead and start with the measure of angle A. Angle A was 2x. So if we know that x is 20, this is going to be 2 times 20. Well, let's work this down actually vertically. If I know that x is 20, this would be 2 times 20, which tells us that the measure of angle A is 40. And when we're talking about the measurement of angles, make sure that you include that degree symbol. So the measure of angle A is 40. We can do the same thing with the measure of angle B. Angle B was our, if we look at the picture, that was represented by 3x. We know x is 20, so 3 times 20 tells us that the measure of angle B is, well, 3 times 20 is 60. And then we can finish up here with our last angle, angle C. If I want to find the measure of angle C, we understand that angle C was 4x. So if x is 20, 4 times 20 gives us 80. So the measure of angle C is 80 degrees. And so again, just to kind of recap, whenever you're given a problem that has an extended ratio like this, what you're pretty much doing is just adding an x there at the very end of that extended ratio, and you'll use that information to set up an equation. So let's look at the next example. The next example here says that ratios can be used to help find the measures of angles. And so now we're going to kind of start to bring back some old vocabulary that we saw earlier on this school year. So in part A, it says the ratio of two complementary angles is 3 to 7. Find the measure of both angles, right? So for these types of questions, I always suggest kind of looking at the vocabulary word, complementary. So whenever you see complementary angles, we understand that these are two angles that add to 90 degrees. And so if my ratio is 3 to 7, we just said that for a lot of these types of questions, whenever we're talking about angles, anything of that nature, or sides even, we can just basically write this ratio the exact same way, 3 to 7, by tagging on an x. So if I have two complementary angles in the ratio of 3 to 7, well, one of those angles could be 3x. The second angle could be 7x. So in this situation here, we can understand that these two angles, because they're complementary, they have to add up to 90 degrees. So our equation that we can write would be 3x plus 7x is equal to 90. And so if we start to solve for x, we got 3x and 7x on the same side, so I can combine like terms. That gives us 10x. It's equal to 90. If I divide by 10, we see that x is equal to 9. Right? But this question was asking you for find the measure of both angles, right? Well, pay attention to what we have right here. Here's the ratio that represents both angles. If one of those angles is 3x, then this would just be 3 times our x value of 9. So that would give us 3 times 9 is 27. So one of those angles is 27 degrees. The other angle is 7x. Well, 7 times our x value of 9 would be 7 times 9 is 63. So our two angles here, the measure of both angles would be 27 degrees and 63 degrees. And you can double check your work by adding those up. Check to see, do those add up to 90? And 27 plus 63 does give us 90. And so let's look at part B. Part B says the ratio of two supplementary angles. So now I see another vocabulary word here, supplementary angles, is 4 to 1. Find the measure of both angles, right? Well, when I'm talking about supplementary angles, these are angles that add to 180 degrees, right? So you'll start to notice that these vocabulary words from earlier on this school year, they pop up again, and they pop up quite a bit, right? So if you haven't learned complementary and supplementary angles, please make sure that you are writing down what supplementary angles add up to 180 and complementary angles add up to 90. So we got the fact that these angles are going to add to 180 degrees. Well, if I look at the ratio that we have here, my ratio is 4 to 1. So we can understand that that's 4x to 1x. These two angles, because they're supplementary, that means that they add up to 180 degrees. So my equation would be 4x plus 1x It's equal to 180. Well, 4x plus 1x is 5x, and that's equal to 180. Now, if we divide by 5 to solve for x, we see that x is equal to 36. And this question didn't ask us to find x. It said at the very end, it said find the measure of both angles. So we're working with this ratio again. My ratio is 4x to 1x, right? If x is 36, then we can start to plug these values in. So 4 times 36 would be 144 degrees. And my second ratio, the 1x, well, 1 times 36 is simply just 36. So my second angle is 36 degrees. All right, so to kind of keep things moving here, let's go ahead and look at example 5. So ratios can also be used to help us find the dimensions in a shape. So the next question, if we read this, it says the ratio of the measures of the sides of a triangle is 8 to 15 to 3. If the perimeter is 182 meters, find the length of each side. Right? So for these types of questions, if you're unfamiliar with them, it might be helpful here to draw a picture, right? So we probably could have drawn a picture for the previous problems. And let's go ahead, I know we're kind of going backwards here, but let's go ahead and draw a picture so that you can understand what this would potentially look like. So if I have two angles here, it doesn't have to be perfect, but two angles that add up to 90, we can understand that one of these angles in this example would have been 3x, the other angle would have been 7x. If I looked at potentially drawing a picture for part B, we can see that if they're supplementary angles, they create a straight line. So they are going to add up to 180. So we can understand that maybe this one was our angle of 4x, this one was 1x. And so for part A in example 5, let's go ahead and draw a picture so we can better understand this problem. So it says the measures of the sides of a triangle. So I have a triangle. Doesn't have to be perfect. They tell us that the ratio is 8 to 15 to 3, right? So I can write this as 8x to 15x to 3x. And so that represents the sides of the triangle. So I can now label the sides as 8x, 15x, and 3x. And they tell us that the perimeter is 182 meters. Okay, perimeter is found by adding up all the sides. So we can now better understand of how exactly are we going to set up our equation here, right? If we want to set up our equation, then we can take a look at using that perimeter, right? The perimeter is 182. The way that we're going to get that perimeter is by taking 8x plus 15x plus 3x. That represents all three sides. When I add up all those sides, I get the perimeter, which they said is 182. So at this point, now we're back to solving for x. If I want to start solving for x here, 8 plus 15 is 23, plus 3. If I combine like terms here, we get 26x. It's equal to 182. If I want to solve for x, I'm going to divide by 26 on both sides. If I do 182 divided by 26, we get that x is equal to 7. And so now it said find the length of each side. So if I want to find the length of each side, one of those sides was 8x. Well, 8x would be 8 times 7, which is, let me do this actually vertically. 8 times 7, which would be 56. So one of these sides is 56, and the units that they told us here is meters. So 56 meters. That's the length of one side. Other side that we had here was the 15x. So x was 7, so 15 times 7 would give us 105. So this would be 105 meters for this side. And then lastly, we have our side of 3x. Well, x is 7, so 3 times 7 would be 21. So this side would be 21 meters. So our answer here, find the length of each side. One of those sides is 56 meters, the other side is 105 meters, the last side is 21 meters. Okay? And so now we'll go ahead and dive into a super important topic that you're going to see throughout this entire chapter is a proportion. So a proportion is an equation stating that two ratios are equal. All right, and so the parts of our proportions are the following. We have something known as the extremes. The extremes represent A and D, and the means represents B and C in this scenario. Okay, so we read this as A is to B as C is to D. You'll start to kind of recognize the next part here, which is known as the cross product property, which this is also known as the butterfly method. So this is known as the butterfly method. Well, essentially what we're doing here is what we're going to do, and we'll see what this looks like as an example off to the side. If I have A over B is equal to C over D. So in other words, if I have a ratio equal to another ratio, or two fractions equal to each other, I can start to solve equations by cross multiplying. Cross multiplying would have us be multiplying diagonally. So what I would have here then is A times D. That would be equal to B times C. And so in this scenario, B and D, the numbers on the bottom, your denominator, can never be zero. Okay, but essentially this is how we solve proportions, right? You're going to cross multiply or use the butterfly method. So this will hopefully start to kind of look a little familiar as we start to look at some examples. So example 1 says solve the variable in the following proportions. If I look at part A, I see here that I have this diagonal and this diagonal. When you're cross multiplying, you're multiplying diagonally. I'm going to start with the x first here. What you're multiplying here is, in green, 6 times x, which is, scroll back down here, 6x. So 6 times x, that's equal to, if I look at the other diagonal, we have 4 times 21. So this is essentially how you're going to set up these problems. You're multiplying diagonally. And now you can go ahead and start multiplying it out. 6 times x is just 6x. 4 times 21 is 84. And so now we have an equation. We're not dealing with fractions anymore. We're just simply solving for x. So our next step here would be to divide both sides by 6. 84 divided by 6 would give us that x is equal to 14. Okay. And so one thing that I didn't mention that is super important so this does not become confusing, when you multiply your diagonals, so the part in green, that diagonal when you multiply is equal to the other diagonal when you multiply, right? So you'll notice that in this step right here, we no longer had a fraction, right? And you'll see the same thing happens again in the next problem. So part B, we have x minus 3 over 2 is equal to 4x over 5. So this one's a little bit more complicated now. And so let's look at our diagonal here. If I want to cross multiply, okay, you can do this with highlighters. You can just circle it if you want like this, whatever is easiest for you. So if we're looking at the diagonal that I have circled in red, this would be 2 times 4x. That's equal to the diagonal that I have circled in green. We have x minus 3 times 5, right? And so your first instinct might be to want to write it like this. However, typically, if we just have a number like that, you're going to write it with the x part second. So this makes more sense if I just write it out the way that I'm asking you to. So much more comfortable to look at if you were to write it as 5 times x minus 3. Okay, but now we can go ahead and start to multiply this out. So I have 2 times 4x, that's 8x. That's equal to, if I look at the right side of the equation, now we need to distribute. 5 times x is 5x. 5 times negative 3 is negative 15. Now I'm going to start to go through this part a little bit faster because we should be comfortable solving an equation like this. So next thing we would do here is minus 5x on both sides, giving us 3x is equal to negative 15. If we divide both sides by 3, we get that x is equal to, well, negative 15 divided by 3 is negative 5. So x is negative 5 in part B. And then we'll look at part C. Part C, same idea here. So we're looking at this diagonal when I multiply. It's equal to this diagonal when I multiply. So if I look at the one in green here first, I got 4 times C. And then that's going to be equal to my diagonal in yellow, which is 6 times c minus 1. And so some of you guys might be wondering right now, is that going to be any different? What if I chose to start with the other diagonal? What if I did 6 times c minus 1 is equal to 4 times c? You're going to get the same answer. So don't stress out about the order. As long as you multiply the diagonals and set them equal to each other, the order won't be super important here. But let's go ahead and start multiplying this out. We have here 4 times c is 4c. 6 times c is 6c. 6 times negative 1 is negative 6. And now we just solve for x. Not x, I'm sorry, but c. I would subtract 6c on both sides here. That would give us 4 minus 6 is negative 2c. It's equal to negative 6. Then divide both sides by negative 2, giving you that c is equal to, well, negative 6 divided by negative 2. Negative divided by negative is a positive, so positive 3. So c here is equal to positive 3. Okay, you'll get more comfortable with these as you start to practice some, and you will have plenty of problems like this in the assignment for today. So we'll finish up here with the word problems here at the end. So example 2 says CDs are on sale at the music store. During the sale, you can purchase 3 CDs for $27. You want to purchase 5 of your favorite CDs. How much will you pay for them? So whenever we're given a word problem like this, you'll start to notice that typically for these word problems, you're talking about two things, right? So let's focus on the two things we're talking about. I'm seeing here that we're talking about CDs, right? Talking about 3 CDs for $27. And then it says you want to purchase 5 of your favorite CDs. How much will you pay for them? What we're talking about here in this problem, the two things are CDs and the cost, the money, right? How much is it? So what I want you to focus your attention on here is find out what your ratios are, right? So these word problems are going to be basically us looking at ratios, right? So here's one ratio right here. Remember that a ratio is a comparison of two quantities. What I'm comparing here is the number of CDs to the amount of dollars that it cost. So I see here when I focus on the numbers, the 3 represents the CDs. The 27 represents the cost in dollars, right? So we can write this as a ratio. We can write this as 3 over 27. And so for these word problems, what I suggest, this takes you literally less than 5 seconds. Go ahead and write out what it is that you're like setting up here. So what we're setting up here is on the top, the 3 represents the CDs, right? And on the bottom, I guess let me use a different color so it's not confusing, but we have CDs on the top, and on the bottom, the 27, that represented the cost in dollars, right? So this represents the order in which we're setting up our ratios, right? So I got 3 over 27. That means that when I look at my second ratio in this problem, I need to make sure that I follow the same order with the CD number on top. So now this 3 over 27 is going to have to be equal to, if I look at the next ratio here, it says that we're looking at 5 CDs, okay? 5 CDs would tell us that, well, this is why we have this part right here. It tells us that we're going to have the 5 on the top. And on the bottom, okay, it's asking you how much will you pay for them. We don't know. So if we don't know, we typically use the variable x. So there is our proportion, right? Setting it up in geometry a lot of the times is the hardest part, right? Now we just do what we did earlier. Now we just cross multiply. So if I cross multiply, I'm looking at 27 times 5 is equal to 3 times x. Well, 3 times x is equal to 27 times 5. And you'll notice that I'm doing this every single time where I write it in parentheses. I do that because in the problems that we saw before, like part B and part C, you have to distribute, right? So it's good practice to always just write it out like this. But it's understood here that if it were just to cross multiply, this would be 3x. This would be 27 times 5, which is 135. And then if I want to solve for x, we just divide by 3. So x is equal to 45. So to answer the question, x represented the part on the bottom, the dollars that it costs for 5 CDs. So how much will I pay for them? To answer the question, you will pay $45. Okay, so just make sure that you actually read the question. Don't just put 45. Make sure that you answer the question, how much will I pay for them? 45 what? 45 cents, $45. So just make sure that you're answering that question appropriately. Lastly, we'll look at example 3. It says, Sarah can grade 10 tests in 30 minutes. At that rate, how long would it take her to grade 125 tests? So similar situation here. For these word problems, we're talking about 2 things here, right? If I look at the ratio here, 10 and 30, well, I'm looking at 10 over 30, and we'll write out off to the side, how is it that I'm setting this up? Well, the 10 represents tests, so I'm putting tests on top, and on the bottom that represents minutes. So my ratio here would be 10 over 30. That's equal to, well, let's look at the second ratio. It says at that rate, how long would it take her to grade 125 tests? How long? We don't know. So 125 would be tests, so that would go on top in our second ratio, and on the bottom, we don't know, so we were going to call that x. So there's our setup. Now we just cross multiply. If I cross multiply here, we got 30 times 125 is equal to, choose a different color here, 10 times x. Okay, so if I multiply 30 times 125, what we get is 3,750, and that's equal to 10x. From here, if I want to solve for x, just divide by 10. If we divide by 10, we get 375. So 375 is equal to x. But again, reread the question. What does that 375 represent? That represents our x value, the number on the bottom, which represents the minutes. So to grade 125 tests, how long would it take her? It will take her 375 minutes. All right, so that's going to conclude the notes for 7.1. If you have any other questions or you found a part confusing, please feel free to reach out to your teacher to schedule a time to come in for tutorials.